In this video, we're going to continue topic 5.3, which is solving linear quadratic systems of equations algebraically. Let's just review how we would solve, or some methods for solving a quadratic. So I'm going to put this just out in the left-hand column. So to solve a quadratic, equation, first thing we're going to do, if we can possibly do it, is to factor. And most likely you're looking at a greatest common factor or some kind of magic X. The second thing I'm going to try is the quadratic formula. And then the third thing that I'm going to do is I'm going to complete the square or solve by roots, the roots method. And that way, so that's the last resort. And sometimes it's just set up better for completing the square. So let's take a look at example 2. So we are supposed to solve the given linear quadratic system algebraically. So what I'm going to do is I'm going to actually use substitution here because I can't really use elimination. So I'm going to try to solve this first one for y. So I'm going to get the 3x on the other side by subtracting it. So that gives me negative y equals negative 3x plus 7. And then I'm going to divide by negative 1. So that's going to give me y equals 3x minus 7. Now I'm going to take this and I'm going to plug it in for the y in the second equation, because the goal is to get it down to a single variable if I can. So I'm going to get 3x minus 7. So that's what I'm plugging in basically for the y. And then I'm keeping the plus 4. Didn't change color. There it comes. Plus 4 equals 2 times x plus 5 squared. So now my goal is to get the x's by themselves. I probably didn't need the parentheses, so I could just add, I'm going to start combining like terms. So I'm going to add the negative 7 and the positive 4. So 3x minus 3 equals, I know that the squared means I need to write it twice. So x plus 5 times x plus 5. Over here, I'm going to FOIL this piece here. So 3x minus 3 equals 2. X times x is x squared. X times 5 is 5x, and I have another one of those in the middle, which gives me 10x when I add them up. 5 times 5 is 25. I'm going to distribute the 2, so I get 3x minus 3 equals 2x squared minus 20x plus 50. I am going to now, in order to solve a quadratic, I know it has to be equal to 0. So I'm going to move the 3 and the 3x to the other side. So I get 0 equals 2x squared. When I subtract the 3x, I would get negative 23x. And when I add the 3, I would get positive 53. Now, I am going to try to do a magic X on that. So that's where I always start. So I multiply the 2 and the 53, and I get 106. And then I get, ooh, not 17. What happened? Did I do something wrong? 3x. I did do something wrong, didn't I? This should have been, I should have, oh, that should have been a positive 20 right here. I must assign up there. So when I'm subtracting that over, I would get 17x. So I get 17 right there. And I don't think there are two numbers that multiply to 106 and add to 17, so I cannot use a magic X. So the next thing I'm going to do is I'm going to try my quadratic formula. So X equals the b value, which is 17. So negative b plus or minus the square root of, and then we're going to do b squared, which is 17 squared minus 4 times the a value, which is 2, times the c value, which is 53. And that's going to be all over 2 times the a value, which is 2. So we've got negative 17 plus or minus the square root of, let's see, 17 squared is, nope, I keep hitting the wrong button. 3, that doesn't seem right. It's 289 minus, let's see, 424 when I multiply the 4 times 2 times 53 all over 4. So I get negative 17 plus or minus square root of, and then 289 minus 424 is going to be negative 135 over 4. Now, we all know how to pluck our eyes out and do that whole process, but because we're trying to solve a linear quadratic system, that means if I have a negative under there that there's no real solution, so there isn't anything that crosses. So when you hit something like this, you would say no real solution and stop. All right, let's take a look at